Going live. And we're live. Hi, I'm Tim Van Milligan. This is RockSim Live, where we talk about the RockSim software. I am your host, Tim Van Milligan. Let me turn on my little marquee right here. I've got a monitor over here where I'm monitoring the chats and people as they're coming into the room. Stuart McNabb says, how are things in Colorado Springs? It's a little bit hazy. All those forest fires from the west coast are drifting into Colorado, and it is pretty hazy, although today is a little bit better than yesterday, so that could be a good sign. Those big fires, they can take well over a month to put out, so when they happen, our summers can be pretty hazy. Normally in Colorado, it's crisp and clear and a beautiful day, but it's going to be nice and sunny today. We're not expecting any rain. It would be a good day for a rocket launch. So if you are new to RockSim, let me show you my desktop here. And let me bring up a web browser and show you just where you can find RockSim. This is the Apogee website. Let me try to make this viewable here. Our web address is apogeerockets.com, and on our website we have this carousel up here that has all kinds of good stuff in it, but there's a RockSim banner, and then there's also a launch visualizer, which we are in beta testing right now. And if you would like to be a beta tester, just click on this banner and it will take you to our page where you can get information on what it means to be a beta tester. Basically, I give you access to the software. It's actually a website, so there's no software to load. You just go to the website, test it out, and send me feedback. And if you send me feedback, I'll upgrade you to what we call a gold member, which means that you have access to all the features like angling the launch rod and changing the azimuth and giving it a spin on the way up, and even launching from different altitudes and pre-launch velocities. So there's a lot of cool things you can do, but you need to be the gold member, and the only way to get the gold member right now is to give me feedback. So go ahead and come to this website. It tells you to go to our contact form, which is right here, and the contact form is always on the right side of the page. And when you go to the contact form, there's this drop down menu right here, and make sure you select RockSim Beta, because if you don't do that, I don't get the email and you won't become a RockSim Beta tester. To get to the RockSim software, there's a couple of ways. If you just want to purchase this outright, just go to shopping, come down here to Rocket Software, and you can choose RockSim or RockSim Pro. We are taking questions on RockSim, RockSim Pro, and the launch visualizer, so we can talk about any of those three things. The questions are up to you. Go ahead and put them in the comments form here on YouTube. If you are watching this as an archive, which means not live, go ahead and just come to the Apogee website and type in your questions there, and we can try to answer them here. If you want more information about RockSim, go to the How-To and Guides menu, come down to Software, and you'll see in this menu there's a lot of things you can do. Like you can get the free trial, you can purchase it. If you want to get just basic information on what is RockSim, click on there. If you want to learn how to use it other than coming to these RockSim live trainings, we have a ton of tutorials. Anything that's specific, go there. There's also the RockSim live training archive. This gives you all the previous episodes that we have done. Today we are on episode number 31. Sometime before next week, it will be listed here on this page. So that's kind of like my introduction. Let me go to the questions over here. We have Vernon from Maryland. Hello, Vernon. We have Deep Thought. Give us a rocket icon, a happy icon, and a live long and prosper icon. No questions yet. I did get one question on RockSim. Let me bring that up. This one came in by email from Carlos in Atlanta, Georgia. He writes, we are interested in exploring some dynamic situations. Simply put, at some stage during the flight, the CG, CP, and or the position of some mass objects will change internally. With modern electronic timers, altimeters, and good old-fashioned sneaky engineering, during some rocking experiments, there may be essentially before and after configurations and during transitions between them. Imagine hatches opening and closing for air sampling, panels shifting or parts departing like Apogee's flyaway rail guides. We are imagining a lot more. We aren't looking for a guarantee or an excuse to try dangerous things, rather than looking for some ways to use RockSim to essentially stay in lower risk stability zone. Okay, so I get the gist of the question. So basically he's asking, let me go to RockSim. So something is changing during the flight. You know, imagine a fin canting, or on a glider, a stabilizer kicking upwards, or like he said, a hatch opening, or drag brakes deploying on your rocket, things like that, mechanical things. Can RockSim or RockSim Pro do this? I've been thinking about this for a long time, and I've been trying to figure out if there's a sneaky way to do it, and unfortunately I can't figure it out. There are flight events in RockSim, and there's 3 of them. So if you go to, you know, prepare for launch, I can kind of show you what they are. Let's load an engine into this rocket. We'll just choose something. There's some big motors here. Let's just choose something like an F-24. Doesn't matter. So you go here to the Flight Events tab, and you click on this, and these are the things that you can use to trigger events during the flight. And so the 3 things are a parachute. You can deploy a parachute. Number 2, you can deploy a streamer. Or number 3 is you can deploy a stage. You can do staging. So you can have a bottom stage and a top stage. And when the bottom stage drops off, that is an event. So how do you use that to trigger things like a flap flipping up or a hatch opening, drag brakes deploying? I'm at a loss because I'm thinking about it, and I just can't figure it out. We need some kind of trigger event, and I've been trying to think about how to do this, and we would have to create something brand new in RockSim called, you know, another event. And when you trigger that event, then you, like he says, the CP can change, the center of gravity can move. Basically, those are the 2 things that can happen. You know, your center of gravity can shift forward or aft, or the center of pressure can change because, you know, you've flipped up a stabilizer, and that shifts your center of pressure. So there would have to be some controls happening with it. It's pretty complicated, and I've been thinking about it, but I can't promise anything in the near term, because in the near term we've got all these other things going on. We just released RockSim Pro. And we trying to get out the RockSim visualizer, the launch visualizer. And that is a big undertaking, and it's quite an investment on our part. So I just don't have time to to do the next phase, and I've already been planning the next phase. The next phase after the launch visualizer, because if you're not familiar with the launch visualizer, let me bring it up here and I can kind of show you. I got to open up a new window here. I got to open up the launch visualizer. I'm doing this over on the side here, and then I've got to change my screen here. Okay, so I am bringing this over. Okay. Oops, I brought over the wrong screen. Here we go. Check this one out. All right, so this is, did it come up? How come it's not showing? Okay, it's on a delay. What you're seeing is happening about 20 seconds after I say it. Okay, so now I can see what you're seeing. This is the launch visualizer, and it's a web page. And I'm kind of, and like I said, to get to this web page, you got to go to that page on our website where we're asking for beta testers and go through the process, and then I'll send you the link to this web page. But I can sign in. Oops, I'm trying to sign in using my Apogee account, and I shouldn't do that. I should just sign in here. You can only sign in, once you pick a way to sign in, either you're signing in by creating an account or signing in through Google or signing in through Facebook or signing in through the Apogee site. The next time you come to the website, you have to choose the same one because for security reasons, we're tying your account to your email address, and how that email address comes in is very specific. So this is the launch visualizer, and what the launch visualizer does is it performs the simulations that RockSim would normally perform, but it does it in a browser so that you don't have to load any software on it. And the big advantage for us is we don't have to deal with Microsoft and Windows or Apple with the Macintosh operating systems. We're just dealing with a web browser. And so we can deploy changes like overnight. And when you're beta testing, things are happening every day. The programmers are constantly working on it. And what I'm seeing today is different from what I saw yesterday. And what we'll see tomorrow is different because beta testers are finding issues and they're fixing them. And new stuff is being added all the time. So if you're a beta tester, and I keep forgetting this myself, you have to clear your cache before you log in because it's trying to remember the old stuff and now there's new stuff. So during this beta testing period, clear your cache before you log in. I had problems yesterday because I didn't clear my cache, and if I would have remembered to clear my cache, things would have worked out just fine. Okay, so I'm just checking over here. We have BNEF says, hello, we missed you at LDRS 39 a few weeks ago, but managed to get our level 2 certification with an Apogee Katana. Cool. Excellent. He got L2 certified using one of our rockets. 421 Rant says, hi Tim, go over canted engine positioning in regards to CG and CP, thanks. Okay, so we'll talk about canted rocket engines, and that is only a feature in RockSim Pro or RockSim Pro. I was thinking, is it in the Launch Visualizer? It's not in the Launch Visualizer. It's only in RockSim Pro. This is the Launch Visualizer, and like I said, this is a web-based software, so you don't have to load any software. So you know, as soon as you go to the web page, you're up and running, and you would come to this screen, and I've already logged in, but if you're not logged in, you can still run a simulation, but your options on positioning the rocket, as I said, are limited. So here, by default, it loaded an Avion. I can choose a different design. So I got a flamethrower, a pterodactyl 2-stage, and I'll click select, and it's just going to reload the rocket that I just asked it to load, and I can see it here sitting on the launch pad. You can see which direction the wind is coming from, and I can orient this around, and so my wind is coming out of the west. And this is just for orientation. Once we go to actually launch, we'll be launching on your launch site. So if somebody would like to tell me their favorite launch site, maybe Stu McNabb, he's been coming here every time and he says he's from Arkansas. So let's see if we can find a launch site near Arkansas. So I'm going to the launch site selection picker right here. And this is the current default launch site, which is our launch site in Pueblo, Colorado. But I'm zooming out so I can get a lay of the earth here. And I need to orient the globe. So here is Colorado. And all these thumbtacks are launch sites. The red ones are NAR, the blue ones are Tripoli. And let's go over to Arkansas and see if I can find one that's close to Stu McNabb. The closest one that I can find is actually here in Tennessee. So I'm going to zoom in on that, keep zooming in, and see if I can find. Okay, so here we have a nice launch site. And now we have to put the pad down on the site, because are you actually going to be launching right there, or are you going to be out here in the field somewhere? So I'm just going to double click here, and that's where my launch pad is going to be. And as I double clicked, it reloaded the latitude and the longitude and the altitude of that particular launch site. Well, actually, that's not this. I got to come down here and confirm the launch site. So when I do that, because I was looking at the altitude, and I know this is not 5,000 feet here in Arkansas, so it shows at 163 feet above sea level. So now I go to orient my rocket, and I can change the orientation so you can see I'm tilting the rocket. And right now I'm tilting it to the north. Let me re-click the home button. And so right now the rocket is tilted to the north, and if I want to make it tilted to the east, I just move it around here on the compass rose. I can also change the orientation here. That's the roll orientation. It doesn't really matter so much for symmetrical designs, but if you have something with wings on it, that's going to make a difference. So now when you got it situated the way you want, then you can go to your weather conditions. I'm not going to change anything on the weather. Then you can load an engine. This is a 2-stage rocket, so I would come down here. I'm kind of looking for the Estes motors, and they were just here at the top. So Estes E15 will put in an 8-second delay, and that was in the upper stage, and I'm going to load the same one in the lower stage. So it loaded it in the lower stage, but I need to change the delay and come here, and I'll change it to a 0-second delay. So now I have a 0-second in the booster and an 8-second in the upper stage. Under flight events, I have a staging event. This staging is going to occur at maximum engine ejection, which is 0. So we'll just leave that alone. And then the parachute is going to, in the upper stage, will deploy at 8 seconds, which is also the maximum ejection delay. And then you just come down here to the bottom and you click launch. And it's going to ask you, do you want to give it any comments? And I'm going to say, hello, Stu. Stu shows up every week, so I can pick on him. And it's running the simulation. And right now we've got this little bug and it's showing the rocket motors outside of the rocket. And so the beta, or our programmers know about it, and they're going to be fixing it. That bug wasn't there before, and it's something that just showed up in the last couple of days. So this is the rocket on the launch pad, and I can zoom out. But down here on the bottom, we call the mini view, which is a close-up view. So you can see the trajectory here, but then you can look down here and see what the rocket's doing. Is it rolling or pitching and yawing as it's going up? This cone right here we call the weather cocking cone, and we want to see the rocket have its apogee point somewhere inside of that cone, because that tells us the rocket is going more up than sideways, because up is much safer than sideways. So now I can start my simulation down here by just clicking the launch button, and the rocket is taking off, and it's arcing, and it's going sideways. So our apogee point is not going to be in the cone. It's going to put a red dot down. So that is our apogee point right there, that red dot. And the rocket is going towards a lake, and the parachute popped out right there. Let me zoom in, and we can see the parachute out. So the parachute is out. I think it's going to miss the lake. This is the beauty of the software, is to avoid those obstacles and hazards on the ground. So let me stop the simulation here. Right now you can see the flame is coming out of the rocket. Let me zoom in, so if you're new to this, you can see that. So you can see the flame is coming out of the rocket, and you can see the smoke being generated. Having everything aligned perfectly on the rocket is quite a bit of geometry, and it's pretty hard to figure out on the fly. And so that's why the smoke is a little bit off, but in general, you know, you can see that it's pretty close to where the rocket is, and you can see here's the launch pad, and the smoke is over here, but what happened was the wind was blowing it, and north is the black arrow on my compass down here. So north is this way, so west is up here towards the upper right corner, so it's blowing this way across the field, and that's why the smoke has been blown that way. And let me drag the slider all the way across so we can see the entire trajectory. And I want to change my view here so I can see the entire trajectory all at once. And you can see the rocket. That was not a good flight. You know, it went way too far horizontal. I would call that unsafe. These red dots, again, are the apogee point. You can see down here is probably where the parachute deployed, because once the parachute deployed, it comes straight down. But it did just miss that little lake right there. The Penal Farm Lake number 3. But I missed the lake. The booster stage landed right over here. So anyway, so that is the launch visualizer. And if you would like to play with this, like I said, go ahead and come to our website and ask to be a beta tester, and I'll give you the link for that. So let me close that window, and now we're back to the RockSim screen. And okay, so we need to talk about canting engines, because that was the question that 421 Rants asked about. Okay, so I need to go into RockSim Pro for that. So I'm going to launch RockSim Pro here in just a second. You can get out of this flash screen by hitting escape on your keyboard. Let me resize this screen here so you can see it. I don't want to cover up what is down here. Okay, so we need to open up a rocket. Doesn't matter which one. I'm going to go into my RockSim designs. Yesterday I spent a little bit of time on the Zephyr Jr., which is one of our newer kits, and I put the decals on And I was so proud of myself because it actually worked. It's hard to put the decals on, and we've covered that in a previous episode. But now let's go canted engines and see what happens. Okay, so we're going to go prepare for launch. I'm going to choose an engine for this rocket. I'm going to choose, I want an E motor, but I want something that's fairly long burn, because when you get a long burn motor, you can really see the effects of canted engines. So, so this E12 has a 3-second burn, so that's why I'm choosing that. And the ejection delay, this is actually an RC motor, so that means it's plugged, and those are my only choices. So I'm going to choose custom, and I'm going to add a delay, and I'm going to add like a 5-second delay. Engine overhang is 0.5. This right here is where we're going to cant the rocket engines. So we got a thrust axis rotation about the x-axis and about the y-axis. And I'll explain those in just a second. But first I want to launch the rocket going straight up, no engine canting at all. So I'm going to click OK for the rocket motor. Flight events, the parachute at deploying a maximum ejection. Starting state, we got a 60-inch launch ride, so that's 5 feet. We want to go, let's go straight up. So I'm just going to type in a 0 in the launch guide angle from vertical. And then the azimuth, it doesn't matter, since we're going straight up, our azimuth is our compass direction. So if you're going straight up, it doesn't matter what our azimuth angle is. What's going to be important is the wind. So I'm going to go over here to the wind table and see what my wind is. And I have a wind coming from the 270-degree direction. So that's from the west. It's blowing towards the east. And it's at 8 miles an hour. And I've got it set for 8 miles an hour at sea level altitude and at 20,000 feet above sea level. So anything between sea level and 20,000 feet, it's 8 miles an hour. So it's 8 miles an hour straight across. I can do multiple layers of different directions, but for this simulation, I'm just going to go straight across. Under launch conditions, this is where we're going to choose a launch site. And here in RockSim Pro, these launch sites are not in the software. These have to be added by yourself, and these are the ones that I added personally. In the launch visualizer, we've already added them in there. But like I said, RockSim Pro came out before the launch visualizer, and so it's a little bit behind. So you're going to have to enter the coordinates of your launch site by yourself. So I'm going to choose Muskegon, Michigan area rocketry club. I've actually flown on this field. And so it's at an altitude of 675 feet, and that's above sea level. And here's the latitude and longitude coordinates. So now I'm going to go ahead and just run the simulation. And in RockSim Pro, when I do display the flight profile, it brings up what we call the launch visualizer. And it's very similar to what you saw in the launch visualizer, the online version, but this one is on your desktop. It all does the same thing, but in RockSim Pro we have a little bit more control. It's a little bit more complicated, so I always warn people setting things up can be, particularly dual deployment. It's set up different from RockSim and the launch visualizer. But we're not doing dual deployment here, so you don't have to worry about that. So again, we have the main view window, and then we have the mini view window down here in the bottom. This particular launch site, why I like it, is because, see, our launch pad was right about there. This is a sewage treatment plant, and these are sewage treatment ponds. And you don't want your rocket landing there. Trust me. They call it the Big Stinky. But it's a nice launch field because they also have these farm fields way out here. And these are huge. It looks small here on the screen, but in real life, these are big fields. So as long as the wind is not coming, so north is straight up, as long as the wind is not coming from the north, your chances of landing in Big Stinky is pretty good, not landing there. And we have it set up so the wind is coming from the west, and it's going to blow across the field towards the east. Okay, so let's launch this rocket. Let me put it on the trajectory view here, which is this button right here. And it reoriented, and our rocket is down there on the bottom. And let's see it. So it took off. You can see the smoke coming out, and see the smoke drifting. The rocket's going straight up. I don't have my weathercocking cone turned on. Let me pause it here and turn that on. So turning on the weathercocking cone, and I also want to display the trajectory path. And okay, so here is where our launch was. You can see the cone. Oops, I went too fast there. I'm just using my mouse to move things around. And okay, so the rocket is up here right now, but the apogee point was there. And this was a really nice straight launch, and it's coming down, and it's going to land right there in the field. Really good launch. Nothing wrong with that one. Let me look at it from the west. So you can see how nice and straight this rocket took off. Okay, so now, okay, keep this one in the back of your mind. It went nice and straight. And now we're going to cant the rocket engine. So I'm going to close this out. And you can see our maximum altitude was 1,257 feet. And that worked pretty good. So we're going to go back to here. And we're going to go choose the engine. And this is where we're going to cant the rocket engine. So now there's two axes here. And this is where it gets a little bit complicated. So let me change screen so you can see what I'm going to do here. Okay, so there's a y-axis and an x-axis. So, and I always get these confused. So we're going to figure this out as we go. But one axis controls this. Okay, so that's going to be one axis. And it also comes in and out of the camera like this. And now, well, okay, so it controls this way. Okay, it's okay. I have to think about this because it is kind of confusing. The way it's set up is one axis is this way, so it's from vertical towards one direction, and then the other axis is like a cone, so you're spinning it around as a cone. So when you cant the motor, typically you only need to cant one direction. But then if the orientation is on the launch pad is important, then you got to rotate it around this way. So this is confusing, and I don't have a better way of explaining it, but we'll see the effects. And if we don't see the effects, then we just have to reverse the polarity or reverse the axes. So let me go back here to my desktop. So let's cant it around the y-axis and see what happens. So let's cant it by 10 degrees. Okay, so we got 10 degrees canted, and we'll click OK. And the only thing we're going to do is hit the flight profile again and just see what happens. Okay, so I saw what happened really quick because I kind of cheated. So if I come back up here to the summary screen, the last simulation that we just ran, it crashed because that's the crash icon right there. That means the rocket hit the ground and bent. The nose bent sideways. Not a good thing. You can see that the maximum altitude here was 159 feet. So by canting the rocket motor, we caused this rocket to go unstable. So let me go back to the trajectory view, see it from what we saw before. And it's not going to go very high. It's only going to go 159 feet. I'm trying to set it up to see it. So now watch this down here at the same time you're watching the trajectory. And it's only going to last 3 seconds. So it's going to happen real quick. Whoa! I need to move it over this way. Smuck. Now this motor, remember, burns over 3 seconds. So when it hits the ground, it's still burning. And it's showing the parachute coming out at Apogee, but that's one of the limitations of the software, is if the rocket is still burning coming down, the software thinks it needs to pop out the parachute, but you actually can see from all the speed and the trajectory of it, this rocket's hitting the ground pretty hard, pretty fast. Let me pause it right here. Let's find the rocket in the middle and zoom in. You can see at this point it is still burning, but it's not producing a lot of thrust because the flame has gotten shorter. That's how you can tell. As the thrust increases, the flame gets longer, and as the thrust decreases, it gets shorter. Just pretty much almost like in real life. And then it smucks the ground right there. Hits the ground. Let me zoom out a little bit so you can see the entire trajectory again. Remember, let me put this around to the north. So north is, almost straight up in the visualizer here. The rocket came off the pad, and you can see the red line here is the ground path, and the green line is the flight trajectory of the rocket. And you can see it's not a straight line. It right here when it took off, it was doing something crazy. Let's see if we can put it back on the launch pad and reorient. I'm trying to zoom out a little bit here, and I want to kind of look at it from like that perspective. And as it takes off, as it clears the rod, all of a sudden I can see a slight bend right here. North in this case is in the opposite direction. Let me spin it around so north is up again, so we can get our bearings on this rocket as it's taking off. So as it came off the launch pad, it went a little bit to the east because the wind was blowing it. But then, the thrust of the motor kind of took over, and and now the thrust is dominating the flight, and it's canted. So on our rocket, the thrust is coming out this way. It's not coming out straight, and it's canted over, and it's controlling the flight, and the rocket's going to crash. Okay, so here's a cool thing though. In RockSim, this is a RockSim Pro feature. This is not in RockSim. So to get this feature, you have to upgrade to RockSim Pro. And it's not an upgrade. RockSim Pro is a subscription service. So you can keep RockSim, and then you can try RockSim Pro for a month for $30. That's the current price on it. It's $30 a month. And with that, you can cant the engine, and you can also cant the fins in RockSim Pro. And so let's cant the fins in this rocket design. So I'm going to go to the rocket designs, find the fin set, open it up. Let me change the size of the screen here. Now you can cant the fins, but you don't see it in the illustration. They're going to look straight. That's one of the drawbacks. It's not a bug, it's just something we haven't figured out how to do yet. But if you go to the radial position tab, and now this is RockSim Pro, this is not in RockSim. You go to the radial position tab, you can see there's a fin cant angle. So let's say I cant the fins 10 degrees, and right now it's going to pivot around the front of the fin. I want to pivot maybe in the middle of the fin, so it doesn't really matter where you pivot. You can play around with this. I want to get the length of the fin. So our fin, I can see the length of the root is 5 inches right here. So I'm going to pivot at 2.5 inches. and then hit the tab key. So it's now canted, but here in the image they still look straight. But when you go to the launch, then you're going to see the effects of this. Okay, so we've got the fins canted, and we also have the rocket engine canted. And we're just going to run that very same simulation. We're not changing anything in the setup. We're just going to see the flight profile again. And now remember, the first time we launched, it went straight up. The second time we launched, it went north because the engine was canted. And now this time, okay, I want to switch it around to the north is straight up. I didn't cheat and see what happened here on this one. So on this one, look at this. We went to 578 feet by canting the fins, and it didn't crash. So that's good. So let's see what that launch looks like. Whoa. All right, so that is a different launch, huh? Okay, so it deployed over here, and you can see that now at this point the parachute is coming out. So now let's zoom in and see if we can understand what is going on this launch. There we go. And I'm zooming in, and I'm going to reset it to the launch pad. So now kind of watch here at the mini view, and see, you can see what's going on, and we'll kind of go slow. The rocket's taking off. You can see it's pitching over, just like it did before. So at this point, the rocket is still going pretty slow. Let me see what the speed is here. It's at 125 miles an hour at 1.4 seconds. And I'm just backing it up a little bit. Okay, so now we're at 96 miles an hour off the launch pad. So that's the relative velocity to the Earth. The absolute velocity is because the Earth is spinning. So the Earth is giving the rocket some speed. So just ignore the absolute velocity, just look at the relative velocity right here. So at this point the rocket's coming off the pad, but because it's going relatively slow, the fins haven't really kicked in a lot of force yet. And until the rocket goes a little bit faster, the faster the rocket goes, the more forces are acting on the fins. And that's kind of why it eventually straightens out. So you're wondering, why did it straighten out? Or why did it cant over? Well, it canted over because the thrust is really high at this point. So it cants it over, and then as it picks up speed, it kind of, it's kind of rotating, and and that's straightening it out, kind of like you're rifling a bullet or spinning it up. And so, okay, so the rocket cants over. Okay, and you can't see it very well, but you can. The rocket is kind of rotating. If you watch the decal on the rocket, you see the decal kind of spinning around over there. So the rocket is now spinning. It's kind of rifling outwards, and you can see it's straightening out right here. And you can see, it's really spinning right here, watching that view. I'm backing it up and then going forward again. All right, and at that point the parachute pops out, and then it drifts right back down to the ground, and it lands actually pretty close to the launch pad, only less than 100 feet away. So that was pretty good. So that's canting fins and canting the motor. So that hopefully answers 421 Rant's question. So let me check my questions over here and get a drink. Let's see if there's any other questions coming in. Hello, Ashley Carrier. Good morning, Tim. Ralph from Oregon City, Oregon. Stu McNabb flies from Tripoli, Missouri, Kansas. Walnut Grove, Missouri. So I picked Stu's wrong launch site. The setting is correct for ejection maximum. Every simulation has approximately 1.5 second delay, no matter. Mike Cook has a question about his particular rocket, but unless I actually see the RockSim file, I can't really answer it because I don't know what's going on, Mike. You would have to, if you want to send me a RockSim file, delete all the simulations all the previously run simulations. So basically, come up here to the flight simulations, highlight all the simulations, then go up to simulations menu, and then choose delete. And this will delete all the simulations, just like this. They're all gone. And then run a simulation. Save the file, hit File Save, and then find the RockSim file on your computer, attach it in an email, and then you can send it to me. That's the proper way. And that way I'm only looking at one simulation, because if there's multiple simulations, like I just did here in this particular Zephyr Junior rocket, I had a first simulation went straight up. The second simulation, the engine was canted. And then the third simulation, the engine was canted and the fins were canted. And so now, which simulation should I be looking at? So this way, if you delete everything and I'm only looking at one simulation, then I'm looking at the exact same thing that you are. So Mike, that's what I would ask you to do. Clint Browning says, getting my rockets ready to launch tomorrow. We had a launch last week, so I'm not launching tomorrow, but it'll be another week before I can launch again. Josh from Massachusetts. Alfred Indy. That blue and white rocket is beautiful. I missed what model it was. I would like to purchase one. That is Alfred Indy. He asked, what is this blue and white rocket? Let me give you the wide angle views here again so you can see it. And this is the Klima Andromeda. And this one is special because this one is a 4-engine cluster. So you can see it's a 4-engine cluster. We talked about this rocket before in RockSim. If you come to the Apogee website, let me bring up that. And you just type in the name Andromeda up here in the search bar. Okay, so I just started typing in it and it found it. And then you can click on it, and here is the Andromeda rocket. And you can see how big it is and what it looks like when you put it on the pad. And you can see it's a 4-engine cluster, so you can see all those motors firing at once, which is really cool. So hopefully that answered his question. We have Paul Oliveri from Myrtle Beach, South Carolina. Reggie Morrow. Al Anzek, he's, hi Tim, I'm still alive. Al is local. Al, you're going to be alive for a long time. Just like everybody else. 421 Rant says, sorry Tim, I meant multiple engines, like 6. Like 6 engines. Well, it's the same process. 421 Rants. And so you have to be in RockSim Pro. Then you have to have an engine, a rocket design with multiple engines. Let's see, Andromeda. USS Andromeda. We need the Klima Andromeda. That is not it. Let me find a cluster rocket. 3-engine with strap-on boost. That's a 3-stage. Complex 2-stage cluster. Okay, so this is a complex rocket design. Let's take a look at it, what it looks like. Okay, so we have on the bottom, we have a 4-engine cluster. Let me turn off the bottom. You'll look at the top. And on the top, we have a 2-engine cluster. Okay, so let's launch it just as a single stage rocket. Okay, you can see we have these motors right here. These bottom 4 are the bottom stage, so that's over here. And the top 2 are this stage right here, and those are 24 millimeters. So we're going to choose an engine. Again, we wanted something with a long burn, because the longer the burn, the more pronounced the effect of canting the rocket engines. So let's cant that one 2 degrees. And let's load that one here as well. We can mix and match. Let me see if there's, where is, I'm looking for the Apogee E6. And I'm not seeing it. Let's go with an E12. Let's 8 second. And let's cant that one a minus 2 degrees. And let's just see what that looks like. Let me flight events. Staging, never stage, because we don't have a motor in it, so it shouldn't happen. This is our parachute in the upper stage. There's a streamer and a parachute in the booster stage. But we're not going to, hopefully this should work without having anything. Our starting state is straight up. Same launch site in Muskegon at the Big Stinky, and see what happens. Okay, so there's 2 rocket motors. We launch, and it looks like a pretty normal flight. Let me zoom out a little bit. It was heading towards the Big Stinky, but it deployed the parachute well before that. But you can kind of see that thrust profile. I had 2 different motors. I had an E9 and an E12, and that's what's causing this. Because you have mismatched thrust, so your thrust curve or your trajectory looks a little bit different. So it comes off, and then it kind of straightens itself out. Did you see that little dog leg right there? Wasn't that cool? So that would be what would happen. Okay, so that's 421 rants. That was still your question. Yes, I used to live in New York, but I moved to South Carolina. I fly now with Rocketry South Carolina. Good shout out. Norman Perkle. How difficult is to upscale designs to high power in RockSim? Actually, it's pretty easy. So let me open a small design here. We'll do the flamethrower rocket. No, let's open an Estes design. Let's see what's here. Alpha 3. That's the one that everybody should know. Okay, so oh, I just crashed RockSim Pro. For some reason, well, let's just open up. I still have RockSim open here in the background. Let's see if I can crash this one. Estes Designs, So this, what I'm going to be showing here is both in RockSim and RockSim Pro. Okay, it didn't crash this time. That was good. Okay, so how to upscale a design. So this is an Alpha 3, and if you go to the engine mount, and just to confirm, it's an 18 millimeter diameter engine mount. So let's click cancel there. Say no. Okay, so to scale a rocket, you go up here to Rocket, and there's a menu choice called Scale, and you just say by scale factor. And how big do you want to make it? So if you want to make it a 2x upscale, or this is about a 1-inch diameter rocket, so we need to do it like a 4-inch diameter rocket. So it's going to be a 4x upscale. And you click OK, and it scaled it up 4 times. All right, and so now let's look at that engine mount tube again. And it scaled up the, don't look at that because that might not be correct, because when you upscale an engine mount, it upscales both the inside diameter and the outside diameter. So now you do have to, so everything on the anything on the outside dimensions, I would trust that just fine. And I think, whose question is this? This is Norman's question. But you do have to come back and tweak other components inside the rocket, because when you upscale, it doesn't have logic to know the inside and outside diameters of specific tubes. So the inside diameter of this particular tube is 2.84 inches, but that's not exactly a 54 millimeter engine mount tube. Let me show you that. If I zoom in here, I zoomed in on the motor mount, and let's load an engine, and you'll see that a 54 millimeter is actually going to be smaller in diameter than this right here. So if I load an engine, and I'll just pick one, it doesn't matter. You can see, you know, that's 54 millimeters is 2 inches. And this tube right here is a lot bigger than 54, but it's not quite a 75. A 75 millimeter would be 3 inches. So our inside diameter would have to be bigger than 3 for RockSim to find that this is a 75 millimeter motor mount diameter. So what you would do is you would, on this particular engine tube, you have to tweak the dimensions, and basically the easiest way to do it is just to choose a new engine mount tube. So I'm going to go to the database tab, and I'm going to say choose from the database, and now I'm going to look for either a 54 millimeter or 75 millimeter, whatever you want. Here's a 54 millimeter engine mount tube. Click OK, and you can see now it fits it much better. So you do have to come back and tweak the inside components, but everything on the outside should be relatively, you know, what you would want. You may have to tweak it a little bit, you know, to what's available. So like here on this body tube, it says an outside diameter of 3.904 inches, where the actual closest tube would actually be 4 inches outside diameter, 4.000, and the inside diameter is 3.9. So again, you have to use human intelligence because there's no artificial intelligence built into the RockSim. So that's the hardest thing in scaling up designs, is figuring out, you know, are there available tubes when you want to scale by an exact 4x or 3x upscale. So it might be 4.05 to get to, you know, to exactly 4-inch diameter to the right tube size. So that's the trick there, Norman. I hope that helps you. But it is relatively easy to scale a rocket up. 421 says, think an N1 where all the engines are canted. So now he's not wanting to cant the engine, he wants to cant tubes. And in RockSim, so the simple answer there is you can't cant a tube, an outside tube in RockSim. You can cant the engine, you can cant fins, but you can't cant a tube. You can't cant. Oh, that's going to be a tongue twister. Paul says, do you know Jesse from the Rocketry Show? Yes, I know Jesse. He's a great guy. He has Lock Skinwalker. He may have a RockSim file, not sure. Paul says, can you review my motor selection question above? Paul says, you have trouble finding the motor you are looking for is the same problem that I experience. Okay, so I was looking for the Apogee E6. And so how do you find a motor that you can't find? Okay, so let's open up a new design. I think I need to get a 24mm motor mount because that's what the E6 was. So we're going back to the Zephyr Junior. Click open. No, I'm not going to change that. Okay, so here, this is a 24mm engine in this. I can see that right here where it says 24mm, and before I wanted an E6 and I couldn't find it. So why is it not showing? So, oh, there it is. Okay, so here, well, this is one issue. Before I hit the sort button, and when it sorts first by the letter. So right now I'm sorting G motors smaller, and if I hit it again, it'll sort from the smallest motor up. Okay, so now it's C, D, E. Okay, but now it's sorting by the next letter after the next number after the letter. Okay, so it doesn't see an E6 as being a smaller number. It sees a 1 being smaller than a 6. So that's why, you know, you see 1, 2, then 3, 3, 6, another 6, another 6, and then 7, even though it doesn't see this combination as a number. It's seeing them as individual digits, and that's how it's sorting. So that's one reason that I had a problem finding it. So keep that in mind. So if you're searching for an E9, well, that one would actually be easier, but an E100, you'd have to start in the ones up here. So an E100 would actually be in front of an E11 if there was a motor called an E100. And now the next thing is the motor actually in the database? And that is a different question. So I'm going to cancel out of this, and the way to check is if a motor is in your database is come up here to the top, and let's go to reload engine data. And this brings, right now it's looking in this folder right here, a folder called data, and it's in a really weird place, and it's hidden in both Macintosh and Windows. But this is the path to get to it. And then inside of there are all the engine files, and I can see there's an Apogee, and this is not the individual motors, this is the group of Apogee motors, and for Apogee we only have two. We have an E6 and an F10. Aerotech has hundreds of motors, so their file is really big. So if you want to see what's inside of those, then you need to open those files up in a program called Engine Edit. And Engine Edit comes with RockSim or RockSim Pro. So let me open up a browser. Okay, and I'm going to go to my applications folder. We're kind of running out of time, so this is going to be the last question. I want to be in my applications, and I want to find my RockSim. We are on 10.3 F65. I'm going to open that up, and you can see the RockSim application here, and then there's another one called Engine Edit. And so I'm going to open up Engine Edit. And I think this is the very, very first time we've shown Engine Edit in RockSim Live training. Okay, so this is what the program looks like. And then you have to go up here to File, Open. And now you got to go to that data folder where everything is hidden. But hopefully it will bring up that data folder. And actually I'm looking in the RockSim Pro 3. I want to go to Apogee Components. Okay, so now I have RockSim 10 and RockSim Pro 3 are the two newest ones. And I have some old data folders also. But RockSim 10 is for RockSim. RockSim Pro _3 is for RockSim Pro. Its engine files are different engine files, even though they're identical. I mean, they're stored in a different location, but the engine files are identical right now. So I'll open RockSim 10. Oops, did I not open the right one? It's not showing anything in there. Maybe it's under RockSim 1. RockSim 1, RockSim 9. RockSim 9 has one. I'm sure it's not that. Maybe it's RockSim 1. I've got so many versions of RockSim loaded that I've got this problem of knowing which one is which. But if you only have one version of RockSim loaded on your computer, you'll only have one folder called data. So don't get confused by what I'm doing here. But here's my data folder. And then I want to scroll down and see, now I'm getting into the RockSim engine. That's what .rse stands for. And then I'm looking for the Apogee. I'm going to click open. And it shows my two motors, an E6 and an F10. And here are the thrust curves of those motors. Someday we'll have to do a tutorial on Engine Edit. We just don't have time today. But this tells me that those two motors are loaded in that folder. You know, when I went to engine data files, those two motors are what's inside of this. And if everything is correct, then you will see them in RockSim when you load an engine. But remember, the sorting is kind of weird, but you should see them. So hopefully that answered Paul's question. Norman says, if it could have the logic to know to factor for things like tube thicknesses. Now you're talking about artificial intelligence here, Norman. And even I don't have human intelligence enough to know. It's a very hard problem. It's not a trivial thing because we were looking at that. And Vernon says, for the egg tosser, when entering the weight of the egg via the mass override, does one just override either half of the nose cone, or is there a better way? Vernon, this is half of the nose cone. I would put the mass object, just the total mass of the egg, inside the upper half of the nose cone, and then just move the mass object as far back. Just look at it on the screen. Say it's like right here, we're looking, say this was a note, we wanted to put an egg inside the nose cone as a mass object. So I would come up here to mass, to the nose cone, add a mass object, click cancel here. An egg weighs about 60 grams. Let me go back to 2D view. So right now it's putting it right here you want to slide it back to where it would be positioned in your actual rocket. So just look at the picture, and where that mass object is where the egg is. And that is the center of the egg, because that would be where the mass would be centered. So Paul Oliveri says, yes, it is under RockSim 1. So when I was looking in my database, that is where the RockSim 10.3 motors are stored in a folder called RockSim 1. The naming convention has something to be desired. So we got to end it because we are 10 minutes over time, like we always are. I really appreciate you coming. We got to change next week. Next week is our new time slot. So instead of being here at 10 a.m. or 12 noon on the East Coast, it's going to be 2 p.m. Mountain Time or 4 p.m. on the East Coast, because I have another event scheduled for Friday mornings from here on out. So from here on out, we're moving RockSim Live to 2 p.m. Mountain Time or 4 p.m. on the East Coast time zone. We get a lot of people from the East Coast, so I want to give you fair warning now, but we will set up so you will know that it's at 4 p.m. Eastern Time. So thank you for coming. I really appreciate you being here. We have a lot of people again today, so this is kind of growing. If you have questions, you won't be able to enter it into the comments section anymore here on YouTube. So make sure, if you're watching this archived, to put in your comments as an email using our website. So use the contact form on our website and say, hey, I have a RockSim Live question, and then we can answer it next time. So this is the end of episode 31. So I'm going to end this stream in 3, 2, 1. Go out and launch something.